Okay. What are you looking at now? It's blowing. Oh, you started recording.
Yes, I started
Okay.
recording.
Well, drop that menu down. Good afternoon, class. Today we're going to look at something continuing what we were talking with at the end of the class on last time. We're going to solve quadratic equations, and we started that the last time. We defined what we meant by a quadratic equation, and we said the first, most basic type of method of solving quadratic equations is by factoring. And we said that we had to have the thing set equal to 0, and then we set each factor equal to 0 and solve the individual linear equations that we get then. I'm going to, let's see, I'm going to say that there are 4 generally accepted methods of solving quadratic equations. I think I'm going to write ax squared plus bx plus c equals 0 is a quadratic equation and there are so many letters there that I think I'm going to say a quadratic equation in the variable x. The letter x is the variable. A, B, C are numbers. A cannot be 0. We can't allow A to be 0 because if A were 0, 0 times x squared, 0 times anything is 0, so you wouldn't have an x squared term. To be quadratic, you must have a x squared term. I'm going to add on, instead of just saying A can't be 0, I'm going to make a stronger statement. I want my A value to be greater than 0. And if my A value, the coefficient of x squared, turns out to be negative, I'm going to change it so that it's positive. We'll see that happening, but let's just make the assumption. We want that leading coefficient to be positive. There are 4 generally accepted algebraic methods of solving. So I'll say there are 4 methods of solving. We're going to look, there are 4 methods of solving a quadratic equation. We're going to look at 3 of those methods today. Well, we've already seen one of them, factoring. There's a 4th method that we're going to wait to discuss until we get to circles. I think I'll Roman numeral these. Roman numeral 1, factoring. And I'm going to make a parenthetical note. We did that in the previous homework assignment. Previous homework. But I'm still going to work a couple of examples just to remind you how we solve an equation by factoring. Let's look at number 2. Let's see, is that it? No. Go to assignments and factoring. Review and practice. Now, no, that's not what I want. I don't want reviewing. Oh, Tony was showing y'all. I went there. Okay. Why is it saying review and practice? That is not what I want. Hold on. Here it goes. Assignments. No, I don't want. Why is it saying review? Did Tony change something? Wait. Did I see a question? Did I see an answer?
We finished in the last class.
Oh, wait a minute. We're not doing factoring. We're doing homework number 5, quadratic equations. Hold on. There. right there. I was clicking the wrong one. There it is.
Oh,
Oh,
let me-
we haven't done these things yet. One. Y'all want to look and see how long these things run so you'll know how long the class is going to be?
No, they don't want to
No,
know
they
that.
don't wanna
They'd
know.
rather journey hopefully.
Oh,
there's
there's Elaine Martin
Martin
Gay.
Gay.
Oh, she's such a nice woman. And we'll start off with number 2. This is like what we were doing there at the end of class the last time. Okay, there. Okay. Let's see. This is number 2. Let me write it down. The instructions should say solve by factoring 3y squared plus 2y minus 8 is equal to 0. 3y squared plus 2. Okay, switch over. We're going to solve by factoring. Remember the last time we said to solve by factoring, we need the trinomial in standard form, descending order, squared variable, unsquared variable, no variable, and we need it equaling 0. Well, that's what we have here. So at least one side looks the way we want it, as that equals 0. I'll write my 2 sets of parentheses. Hey, that last sign's a minus. What do we know about the signs inside the parentheses? One of each, one plus and one minus. And so I'm just going to make a note. We're going to have a plus and a minus. We'll fill that in later. This first term, we know first times first has to give us 3y squared. Well, fortunately for us, the only positive integers that multiply together to give you 3 are 1 and 3. So we can use a 1y and a 3y. For 8, let's see, what have we got with 8? We need what times what is 8? 1 times 8 or 2 times 4. And let's see. 2. What do y'all want to try? I'm going to all tell me which one you want to try.
2 and 4.
Try the 2 and 4. Do you have a general feel for where you want to put it? What do you want to put here? It makes no difference to me. I think let's just try putting the 2 there.
That makes no difference. It means
To me, which one you try. It does matter. You can't, if the 2 works with the y, you couldn't have put the 4 there. I mean, it just doesn't matter which one you call out. Okay, so
but I think you
let's see. Let's look at this. We look at the outer product and the inner product. The outer product, y times 4, that's 4y. The inner product, 2 times 3y, that's 6y. Remember, if that last sign is a minus, these things have to subtract to give you that middle term there. Can you subtract 6y and 4y so that you get a positive 2y? Yes. With positive 6y, for 6y, what do you think? Does it need to be positive or should it be negative so that when we combine them together, we get a positive 2y? I'd say the 6y needs to be positive.
That's what they said.
And I agree, so that means the 4y needs to be negative. 6y minus 4y, sure enough, that gives us a positive 2y. So let's stop and think. What do we need to have here in front of this 2 so that we get a positive 6y? Do we need a plus here or a minus? A plus. And then we use the minus there. That gives us a minus 4y, a plus 6y. That certainly does add together to give us a positive 2y. I should say subtract to give us a positive 2y. Now, once we have it factored correctly, we set each factor equal to 0. Y plus 2 equals 0. We have to isolate y. That'll give us y equals. Okay. What I like to do, instead of minus 2 from both sides, I just pick the thing up, move it to the other side, and change the sign. So we've got our first answer of -2, set 3y minus 4 equal to 0. We undo the addition subtraction first. Move that -4 over. That gives us a 3y equals +4. And then what undoes that multiplication? 3 times y. What are we going to do? Divide to give us y equals, for our second solution, I'm running out of room, aren't I? 4/3. So 4/3. So if we plugged in -2 in place of those y's and simplified, the left side would reduce to the 0, just like the right side. If we plugged in a +4/3 in place of those y's and reduced, the left side would reduce to 0. Any questions there? Punching those into our answer, -2 and +4/3. Remember to type a comma between the -2 and the +4/3. And we'll go on to number 3.
And I don't know how this one got to be number 3.
Oh. Well, that wasn't what I thought it was. I glanced at it earlier. I thought it was a number other than 3.
Okay,
Well, we should have done number 3 first. This one's easier than number 2. Why is this one easier than number 2?
What's already done for
It's already been backwards.
you? It's already factored. Yeah.
9c plus 7
We have a 0 with it
times
factored.
2c minus 6 is equal to 0. 9c plus 7, 2c. Well, when I start preparing the classes for next semester in November, let's make a note to reverse problem, to make this maybe
Problem
number
1,
1,
yeah.
right? We'll never remember that. It's already it's already factored on one side, 0 on the other. All we have to do is just set each factor equal to 0.
Show how to pull your skip on problem 2. This problem's
We have skipped to this point right here where we already have it factored. It's already factored form equals 0. So there's only one. What do you think I'm going to do to solve for C? And this one here, what will I do first? Move the 7 over by subtracting, so that'll give us 9c equals -7. And then to undo that multiplication, 9 times c, what am I going to do? Divide by 9 to give us c equals -7/9. There's my first solution, -7/9. The second one, what will I do first here to get c by itself? Okay, so I'm adding 6 to both sides to get 2c equals +6, and then divide by 2 to give us c equals +3. Any questions there? Okay, go to my lab to type in the answer. And occasionally, depending on what programmer was working on, program the problem, occasionally the programmer may allow a comma to appear in the denominator of a fraction. Not always. In a couple of assignments when we get to interval notation, you put a comma in a denominator, it's just going to say wrong and not even give you a hint on what's wrong. So make a habit. Never type a comma in a denominator. Look at how Tony put that comma there.
I'm going to double down and do more wrong.
Is that what we wanted to type? Certainly not. This 3 is not in the denominator. And they might allow some problems. For in this section, there are certain problems, not all of them, but some of them let you type a comma in the denominator and they count it right. That's just bad form and it creates bad habits. So my advice, never put a comma in a denominator.
See the difference between where the comma is now?
It's between, now type the 3, that makes it more obvious.
Okay. Mm-hmm. Okay.
Okay, I said that there were 4 methods of solving quadratic equations. The first one, factoring, we've done the last time. So let's go on to the second method. The second method, I'm Roman numeraling these. Remember the first one I said was factoring. The second one, the square root method. Square root method.
I think if you just do x squared equals 25, they can figure it out.
I'm sure they can. Let me write out the square root property. Here's what the square root method says. It says that if you have something squared, if some variable quantity is being squared and that equals a number, then the thing that's being squared has to be either the positive or negative square root of that number. And if you think about it, that should make sense. That should be logical. What numbers, there are 2 of them, what numbers can I square to equal positive 25? 5 is one of them, I agree, but there's another
Well,
one.
positive 5
Positive 5 is one of them. What's another one? Negative 5. So using this property here, this says that if you have a variable quantity squared equals a number, then that means, using this property, that says that x has to equal the positive or negative square root of 25. So we have a positive 5 and a negative 5. My lab now has a plus minus hot button, so we won't have to be typing the answers 5, comma, negative 5.
Over 5 years.
I know, but I remember back in the day when they didn't have it. Okay, so let's look at number 4.
Oh.
Okay, 2x squared is equal to 22. Okay, switch over to mine. To use the square root method, you need something being squared by itself on one side, and you need a number on the other side. Well, what's being squared right there? That little square, what's it being applied to? Is it being applied to the 2? So we really have a 4. What's being squared? Only the x. So we need that x squared by itself. So before we do anything else, divide by 2.
That's the only correct first step.
If you're going to use the square root method, that is the only correct first step. You need the thing that's being squared to be isolated. You need something squared equals a number. And then, according to the square root method, what sits in that form? You drop the square on the left. So you just have x equals, but you pick up a plus minus square root on the right. What about the square root of 11? Is 11 a perfect square? What's the largest perfect square that divides evenly into 11? Is there one other than 1?
4, 9, 6, no.
Go back to the first day of class. Is there a perfect square that divides evenly into 11? So can we reduce the square root of 11? There's what you're going to type in. A plus or minus square root of 11.
Notice, I've mentioned this before, that you don't see the little tools until you click in the box. Now I know this isn't a box, it's a rectangle. Boxes are three-dimensional. That's just two. So here's the little plus minus.
Y'all see the plus minus hot button there? I remember when I saw it the first time. Tony and I were teaching in classroom side by side, teaching the exact same thing, college algebra, 8 o'clock in
Doing
the
the
morning.
exact same problems.
We click there to type in the answers, and oh my God, there's a hot button, a plus minus hot button. So I leave. Tony's at the same point in the problem. We meet halfway in the hallway. Did you see they put in a plus minus hot button?
We just thought we were crazy, but literally,
that made my day.
for years and years and years, there was no plus minus. You had to put square root of 11, comma, negative square root of 11. So,
okay, number 5.
So with the square root method, it has to be variable squared or something squared equals a number.
Variable expression squared equals a number. That's the form that we need. This is number 5. Let me write it down. 3x squared plus 6 equals 0. This equation is definitely not in the form that we need. Okay.
You know, it's always a good thing when you start a new problem this low on a page.
Yeah. Generally, if I think, oh, I can finish it in this space, I don't like to go to the next page when I'm working examples up here. And the fact that I'm starting right here means this should be pretty short. Or else I can just wrap around and write here, write 2 columns. But hopefully we won't have to do that. We need the equation in the form something squared equals a number. I can get that equals a number easily. I'll pick this 6 up, move it over. That's going to give me 3x squared equals. 3x squared equals negative 6. Subtract 6 from both sides. Or just think the 6 goes over, changes the sign. Now, is 3 being squared?
No.
If the 3 were being squared, they would have had to write the problem like this. There's my scratch work. It would have had to look like that, and that's not what we want. That's not what we had. Notice, if they'd wanted to square that 3, it would have had to be enclosed in parentheses, and it isn't. So, we divide both sides by 3. That gives us x squared equals negative 6 divided by 3 is negative 2.
Is it ready to use the square root method? Can we drop the square?
Do we have something squared equals a number? That's what we need. Something squared equals a number?
Yes.
Yeah, that's it. So we're going to drop the square. We'll just have an x equals, we drop the square on the left, we pick up a plus minus square root on the right. If we go and type in that plus minus square root of negative 2, my lab's going to count it wrong. On the second class day, we said you can never leave a negative number under a square root. What are we going to have to do with this square root of negative 2? We're going to have to make it an I. So it'll be a plus minus. We bring the negative out, becomes an I. The square root of 2 just stays as the square root of 2. Do you all remember that? The square root of a negative number, you have to rewrite it using I. And there's no perfect square factor that divides in evenly into 2, so there's nothing we can do to reduce the square root of 2. We're just stuck with positive, negative, positive or negative I square roots of 2. Any questions there? So when you're factoring, you generally you don't expect to get imaginary solutions. When you're factoring, you have linear expressions, and the things you get, you don't wind up with square roots and negatives.
Either integers or fractions.
But with this square root method, you could pick up imaginary numbers, so don't be surprised by that.
And square roots too.
And square roots also. So type in, click in the box, and now the toolbar appears. You click the plus minus, then the square root.
Sometimes students know an I.
Oh yeah, the I.
Sometimes students say, wait, there's no I down here. Just use the I on the keyboard.
And then the square root of. Any questions there? Those of you over there in that peanut gallery, any questions? No? Okay. Now, if you have a question, you need to call out, because you notice I'm looking down most of the time. That's true for y'all in this room here too, okay? If you have a question, call out, because when I'm looking down at this paper, I don't see what's going on out there in the classroom. I think we better do another one.
Like in the olden days, when your back would be to the,
to the board, yeah.
Your back was to the students, and you were facing the board.
Yeah.
Oh, wow.
Mm-hmm.
Oh, look at this. It's a multiple choice. Well, I'm not going to show all the topics.
And all the possible
all the
answers.
possible.
This is number 6.
Don't let this panic you or scare you too much.
No,
I know it looks sort of bad.
Mm-hmm.
We keep talking about something squared equals a number. We don't just say use the square root method when you have x squared equals a number. But
some algebraic expression squared. And I claim, even though this thing is a binomial here, I claim we have it in the desirable form. We have something squared equaling a number. So
you're already right. It's already in this form.
Something squared equals a number. Well, what's being squared for this problem? What's being squared here? I'm going to drop that square, and what am I going to write here?
2x.
Okay, you drop the square, and you have that 2x minus 2. Equals, what we drop the square on one side, what do we pick up on the other side? A plus minus square root. Don't forget the plus minus. Everyone remembers the square root. I forget the plus minus, though. Am I going to have an I in my answer?
No.
No, I'm not going to have an I in my answer because this number here is not negative. Can we reduce the square root of 21? Is there a perfect square that divides evenly into 21? 4, 9, 16? No? So this is nice. The square root of 21 is just going to stay a square root of 21. We need to get the x by itself, though. So we're going to treat that plus minus as if it were just a plain old operation. Addition, subtraction. We're going to treat it as if it's just a single operation. We need x by itself. What will I do first? Okay, I'll get rid of that negative 2 by subtracting 2.
No, by adding 2.
By adding 2. Adding 2. And notice where I'm going to, that minus 2, when it comes over here, what's it going to become? A positive 2. So I'm going to have a 2x equals, that negative 2 is going to move over and become a positive 2. And I still have that plus minus the square root of 21. When you move the term over, put it in front of the radical. So that negative 2, you moved over, it became a positive 2. And you can't add or subtract these things because they're not like radical terms. We saw that on the first day of the class. You have something with a square root and something that isn't, you're just stuck with that, okay? Now, looking at this 2 times x, what are we going to do to get x by itself? Divide by 2. The 2's cancel, so we're left with x equals 2 plus or minus the square root of 21 all over 2. Now, there are 2 different approaches for reducing fractions in this form. If there were an I here, then we saw that in homework assignment number 2. If there had been an I on top, we'd have to split it up and cancel individually. That's if there's an I. If there isn't an I, you look at the 3 numbers outside of the radical. This number, I don't see a coefficient on this. So there's no coefficient, so a radical is like a square, a variable. If there's no coefficient, you assume it's a 1. 1, 2, and 2. What's the only positive integer that divides evenly into 1 and 2? No, 2 doesn't go evenly into 1. 1 divide, I think 1. You can't reduce this any further. This is reduced as far as it can be. If there's an I, we're going to split up and separate individually the way we did in homework assignment number 2. If there's no I, then we're going to look at the 3 numbers outside the radical, and if there's a common factor, we'll factor and cancel. I think what we need to do right now, before we go any further, we need to type in this answer.
No, I don't have to type it in. It's multiple choice.
Oh.
Yeah.
Oh, yeah.
This gives you a hint of what this used to be like way before. If you go back 15 years, Pearson, my lab, it was a lot of multiple choice. Is it C?
Yeah, 2 plus or minus. That's the only one.
There's only one, yeah, that even looks
close.
like it. Okay. Okay.
Any questions? So yes.
The binomial was squared at the beginning, and you broke down that square by squaring the other side?
I did square rooting. We dropped the square on the left. We picked up the plus minus square root on the right. Basically, the square root of a quantity squared, well, that we saw in, it was in assignment 2, didn't we? We saw that the square root and the squares undo each other. So you dropped the square there, but you picked up the positive or negative square root on the other side.
Basically, doing this without showing it.
The square root squared is just 2, that's canceled out. You still have that square root and the positive or negative possibility on the right. We need to look at how we're going to reduce these answers. I'm going to be very consistent. If there's an I on top, and as we go through the assignment, sometimes there'll be an I because that radical number under the radical will be negative. If there's an I, we're going to split up and cancel individually. If there's no I, we're going to try to factor and cancel a common factor if there is one. I'll tell you right now, if there's no coefficient in front of the square root, you're not going to be able to factor and cancel because the only thing that divides evenly into 1 is 1. Dividing everything by 1 doesn't change anything. I want us to look at...
How about say reduce? Here's a fraction of it.
I have them right here. I have it right here.
Oh.
Okay, here we go. I want to compare 10 plus or minus 14i square roots of 5 all over 5. We're going to reduce that. And then when we're through, we're going to reduce, suppose there isn't an I. 10 plus or minus 14 square roots of 5, all over 5.
I'll take 6 for the third, so.
No, I'll do several. Oh, this was a bad problem, wasn't it? Change that 5 to a 6. You're right. Change that to a 6. If there's an I on top, you're going to separate, okay? 10 over 6 plus or minus 14i square roots of 5 over 6. Do I remember doing this in the second homework assignment?
Problems 3, 4, 5.
Mm-hmm. And then
from
there at the end when we were dividing also, so that would have been what, probably 14 and 15.
10 over 6. How can I reduce that? What can I divide above and below by?
Okay, I can cancel above and below a 2. 10 divided by 2 is 5. 6 divided by 2 is 3. Plus or minus, let's see, 14 and 6. Those also have a common factor of 2. 14 divided by 2 is 7. 6 divided by 2 is 3 to give me 7i square roots of 5 all over 3. If it were complex, if there'd been an I in it, here is what I would be entering as my final answer.
And if you don't enter that, it counts it wrong. If there's an I, you've got to split it up as 2 separate terms.
They want it in the form A plus or minus BI. The I term has to be second. The term that doesn't have an I, the real part of the complex number, needs to go first. Whereas with this, 10, 14, and 6, you're looking at the 3 numbers. There's no I, so we're not going to split up. There are 3 numbers outside of the radical, 14, 10, and 6. What number divides evenly into those? There's a number that divides evenly
into
all 3 of them. What is it, other than 1? 2. So you're going to factor out a 2. You're going to factor out a 2. 10 divided by 2 is 5, plus or minus. 14 divided by 2 is 7, square roots of 5. And then you cancel. 2 goes into 6 3 times. So we have 5 plus or minus 7 square roots of 5 all over 3. If there's no I, this is the format they want. A single fraction, but with no common factor. 5, 7, and 3. What's the only number that could divide evenly into 5, 7, and 3? Just a 1. So that's what you want. You want there to be no common factor other than a 1.
And once you do enough of these, you'll be able to look at the 3 numbers, 10, 14, 6, and probably go from there to here just by saying, okay, 10 divided by 2, 5. 14 divided by 2, 7. 6 divided by 2, 3. Now, you know what? Now might be a good time for you to just do this one with the 5 down there to show that you can't simplify.
I have 2 of them I want to do.
Okay.
Mm-hmm. Okay. Okay. One more example. 8 plus or minus 14i square roots of 5 all over 4. And I want to compare that to 8 plus or minus 14 square roots of 5 all over 4. Let's say you're going through you'll be getting answers that look like these, especially when you're using the quadratic formula. So let's say you go through, you solve an equation, you get to this point here. You see that there's an I up there, so you split up 8 over 4 plus or minus 14I square roots of 5 over 4. Then you reduce individually. 8 divided by 4, that's nice. What's that going to reduce to? 2.
2. No fraction.
Plus
there.
or minus. You look at 14 and 4. Well, they're not going to cancel out completely because 4 doesn't divide evenly into 14. But I think there's a 2 that's common. 14 divided by 2 is 7. 4 divided by 2 is 2. So the imaginary term is 7I square roots of 5 all over 2. If we were using the quadratic formula or the square root method and we got an answer like that, here's how we'd have to type it in for it to be counted correct. A plus or minus BI, the real part and then the imaginary part. Any questions there? Let's compare it to when there isn't an I. Without an I, 14, 8, and 4. What's the largest number that divides evenly into those three numbers? 2. So we're going to factor out a 2.
Or just divide the three numbers by 2.
I'm going to say divide by 2. We're going to divide through by 2. Okay. 8 divided by 2 is 4. Plus or minus. You're only looking at the things that are not under the radical. 14 divided by 2 is 7. That 5 stays under the radical. You tell me what the denominator is going to be. 4 divided by 2 is 2. For my final answer. If there's no I, they're not going to separate. They're going to factor and cancel. If there is an I, that's when you split up and reduce the fractions individually.
If you had done this dividing by 2 over here,
and you got 4 plus or minus 7I square roots of 5 over 2, my lab will count it wrong. They're expecting you to know complex solutions. You write in real part plus or minus the imaginary part. Yes?
I was curious, I see what you did there. Why doesn't I cause us to separate?
oh, what?
Why doesn't I?
Oh, well, you can put the I.
Technically, I is separating. That's all multiplication. That's saying 7. Multiplication is commutative, so you can reverse the order of the factors. 7 times I times the square root of 5 is 7 times the square root of 5 times I. Just make sure it's clear that the I is not underneath a square root, and we still have all over 2. You could either leave that I up on top, or you could have the I out on the side. So it's A plus or minus, here's the B, times I.
But this is easier to type.
This is easier to type. They will take it. They'll take it. If you type it in as 2 plus or minus, and you put all the number there, and then the I out beside it, they'll take it. Okay. Technically, I suspect that's the form they would prefer, but it's just such a hassle. They take this form here. This is where a textbook would write it. It's easier to type, so I'll leave it the way a textbook would show it with the I on top. Did y'all understand his question?
Very good question.
It was a good question. Hopefully I answered your question. Let's go on to number 7. Another square root method problem, I think.
Mm-hmm.
Oh, what's another?
They don't even have to. There's not a whole lot of these multiple choice.
z plus 6 quantity squared is equal to -11. Switch to my paper. Hopefully I remember what we were doing with the square root method. We said you had to have the equation in the form something squared equals a number. I think that's what we have here. Something squared equals a number. So we can drop the square on the left side, just have z plus 6 equals, what do we pick up on the right side? We pick up the plus or minus square root of -11. And I heard someone answer this next question I'm about to ask. What are we going to have to do about that negative there? It's going to have to become an I. But what about the square root of 11? Can we reduce the square root of 11? 11's a prime number. It's just going to stay under the radical. So we're going to have z plus 6 equals plus or minus, I'll put the I, and then the square root of 11. There's only one step left. What is it? Subtract the 6. We need to get that z by itself, so we'll subtract 6, and don't stick it over here. Have that plus minus in the middle, that standard form, to have that plus minus connecting the constant that we just picked up. Say that's 6. So we're going to have a -6 plus minus I square roots of 11. -6 plus minus I square roots of 11.
Which one is it? They all look alike. Is it A? And I think there's only 3 choices here.
If there's only 3 choices, you only have one opportunity to choose the correct answer. If there's 4 choices, you have 2 opportunities.
If it's free form,
if it's free
not
form,
multiple choice, you have 3.
If it's free form, then you have 3 chances to type in the correct answer. But
Final
here, notice
check.
it says final check. That's saying that you only have one shot to get this right. If you get it wrong,
Then
you're
you
going to
gotta
have to do
say
a similar
question.
question and do it again. Any questions? Okay, Roman numeral, let's see. I said there are 4 methods, 4 generally accepted methods of solving quadratic
You're only doing 3
equations.
today.
We're only doing 3 of them today. Factoring, square root method. Normally, Roman numeral 3, completing the square, we're going to do that with circles.
Yes.
Completing the square.
We'll discuss that later. By later, I mean another day.
Yes, we'll see that with circles. I'll just say later. So Roman numeral 4.
Let them write the
no.
What happened?
Oh, I wrote it too soon, didn't I?
Oh,
Okay.
you too.
Roman numeral 3. Completing the square, we'll see later. We are moving on to Roman numeral 4, the quadratic formula.
The quadratic formula will solve any quadratic equation. Like factoring, it isn't always good because sometimes stuff can't factor. Also, that square root method only solves things that you can write x squared equals a number,
Quantity squared.
or parentheses squared equals a number. Okay, so the first 2 methods we saw don't always work.
Well, with completing the square, if we had looked at that now, it could take
It would
something
always
that the completing the square takes something that's not in the desired form and converts it to a desired form to use the square root property. But as I said, we'll see the square completing the square later at a better time. There's never a time that completing the square is the quickest method of solving a quadratic equation. Okay,
In fact, it's the longest.
yeah, it's the longest method. So we'll see completing the square.
Why don't you state that quadratic
I'm going to.
formula?
Oh, the quadratic formula. What am I doing? Thank you. formula. I'll say solutions to ax squared plus bx plus c equals 0 are given by x equals, it's a fraction, you change the sign on the b term, negative b plus or minus, we have the square root, underneath that square root, it's b squared minus 4ac. Now see why I said if I ruled the world, I'd outlaw these. Well, no, I guess I just wrote the word by. There that y is. You see it's interfering with what I wrote down there. Can y'all read that? That's b squared. I'd have to figure out something. I think we'd have to change the alphabet. All the letters couldn't allow these lines like that. They wouldn't go below the line.
Well, you could do that if you ruled the world.
I know. I'm gonna add that to my list. Instead of outlawing, I'm just going to change the alphabet. Instead of outlawing variables that have tails on them, because that y is not a variable. And so it'd still be stuck there. Even if I outlawed the variables with tails, I'd still be stuck with that. Now, that's something we can work towards, changing the alphabet so that nothing goes below the line. What do you think? A, B, C, D, E, F, or G is the first problem. Okay, we'll figure out. We'll think about that. We're not through with the formula. It's negative b plus minus the square root of, can y'all read that? B squared minus 4ac all over 2 times the leading coefficient a. Each time we solve an equation using the quadratic formula, I'm going to write down that formula, okay? So by the time we're through with this, you'll probably have that formula memorized, nearly memorized. We're going to do number 8. And notice there's no more multiple choice at this point. It says solve. I'm going to use the quadratic formula to solve the equation. Here's something I've noticed. If they tell you to use the quadratic formula, then the equation is not factorable.
Sometimes students say, well, wait, can I factor it? Well,
if you're able to solve it by factoring, great, do it. But if the instructions specifically say use the quadratic formula, they're trying to tell you, hey, this thing isn't factorable. At least I've noticed that's usually the case. Maybe they have one here that will be factorable. They say to use the quadratic formula, but I haven't run into any. If you're going to solve an equation using the quadratic formula, just like with factoring, you need the polynomial, the trinomial in standard form, squared, unsquared variable constant on one side, you need a 0 on the other side. Now here's an added restriction. I think I stated this earlier. I want that a value to be positive. If that a value, if that leading coefficient isn't positive, I'm going to move the terms around in a way so that the coefficient on the square term becomes positive. I don't see a number there in front of that y squared. What's the assumed coefficient? 1. 1's a positive number. So what I'm going to do, I'm going to pick up this minus 7. I'm going to move it over. And that minus 7 is going to become a plus 7. So I'll have a y squared minus 6y plus 7 equals 0. And now I'm going to identify my a, b, and c values. A is the number in front of the square variable. So a is 1. B is the number in front of the unsquared variable. Take that sign, that's a negative 6. And C is my constant of 7. Rewrite the quadratic formula. Negative b plus minus the square root of b squared minus 4ac all over 2a and let me move that. Negative b. Negative b. That is saying change the sign on b. This negative b is just saying go to b and change the sign. What's the negative of negative 6? Or the opposite of negative 6? What am I going to write here? Just a positive 6. That's saying change the sign on b. B squared. B squared, I can do that in my head. Okay, negative 6 times negative 6 will give me a positive 36. So b squared, I do that in my head. Minus 4 times a times c. Okay, so a is 1. And what's c? 7. That 7 looks funny, doesn't it? All over what? 2 times a. 2 times 1 is 2. Any questions up to this point?
I highly encourage the b squared and the 2 times a. You do that in your head or on a calculator without showing steps. Now, if you're going to use your calculator to square negative 6, be careful.
We know negative 6 times negative 6 is going to be positive 36. Negative times negative is positive. But look at what he just did there on that calculator. What's he about to get?
I got it. This is wrong. Why? I entered it wrong. To square a negative 6, you've got to put the negative number in parentheses. Because you want to square that negative 2. What I've typed right here is just negative 6 times 6. The square goes only to what's immediately beside it, the 6. I want the square to apply to the parentheses and include that negative. 36. And then the 2 times a, 2 times 1, just do that in your head. Sometimes showing too many steps makes it more difficult than helpful. Under that square root, 36 minus
4 times 1 times 7. Well, I know what 4 times 1 times 7 is.
That's 28.
So we have 36 minus 28.
36.
What's 36 minus 28?
I don't want to call it out.
36 minus 28 gives me the square root of 8 all over 2. Are we through with the problem? No. Are we going to have an I in our answer? No, because that 8 is a positive number. Now the square root of 8. Is 8 a perfect square? No. What's the largest perfect square that divides evenly into 8? 4. So here's how I'm thinking of it. Here, this green is just my thoughts. That's the square root of 4 times the square root of 2. The square root of 4 is 2. What am I going to do with that square root of 2? Let's keep it there as the square root of 2. All over 2. The square root of 8, y'all all got real quiet. Y'all remember doing that? It's the first day of the semester. We ask, what's the largest perfect square that divides evenly into 8? It's a 4. So we said the square root of 4 is 2. That remaining 2 stays under the radical. Is this my final answer? There's no I, so I'm not going to split it up. But if you're not going to split it up, there's something you have to check on. What is it?
2 divides evenly.
Okay, 2 goes evenly into all 3. 2, 6, and 2 are all divisible by 2. So, I'll show you my thought. I'm going to show I'm dividing through by 2. 6 divided by 2 is 3, plus or minus. 2 square roots of 2 divided by 2 gives me just 1 square root of 2. This answer is working out nicer than I was expecting. What can I do now? Cancel the 2's. So I don't even have a fraction. I just have 3 plus or minus the square root of 2 for my final answer. Any questions there?
Let me refocus.
Any questions?
So let me top that in. 3 plus or minus the square root of 2.
Any questions there?
I think starting with number 8, every one of them is quadratic formula from here on.
Number 9. Okay, let's see. Let me write it down. Let's go back to this. I'm going to point out something. When you solve an equation by the quadratic formula, if you're left with the square root in your final answer like we are here, that means factoring. The expression is not factorable. For a second, it looked like this could have been factored. Y minus 7, y minus 1, but you wind up adding the 1. 7 and 1 would give you the 8, not the 6. And I'm 100% confident you cannot factor that because when we solved the equation, you were stuck with the radical. If it's factorable, you do not expect to have radicals in your final answer. And if you have radicals, that means it's not factorable. Okay, looking at this one. Same instruction, solve using the quadratic formula. Okay, we're going to use the quadratic formula. Am I going to have to move stuff around, or is this in the desired form already?
We're going to have to move things around.
Okay, what are we going to move?
The 1.
Okay, we'll pick up that positive 1. We'll move it over by subtracting 1 to give us 2x squared minus 5x. 2x squared minus 5x. We're going to have an equals 0 here. What are we going to have here? Minus 1, I agree. Then we can identify our A, B, and C values. Oh, by the way, one thing you would not want to do, you don't want to pick these terms up and move them over to the right, because if you pick this 2x squared up and move it over, instead of a positive 2x squared, what are you going to have? A negative 2. That's why I'm moving the 1 to the left. As we go through these, if I have a square that with a negative leading coefficient, I'm going to move the stuff over to the right and get the 0 on the left. But that's how I'm going to make sure that my A value stays positive.
Never want A to be negative.
And if it is, you need to move the terms around, as you'll see us doing later, so that you do get a positive A value. Let's identify our A, B, and C. I'll get us started. A is a positive 2. Is that visible?
Oh, is that too dim?
No.
Okay. Oh, dear.
A is positive 2. What about B? What's B? Negative 5. Remember, take that sign. And C? I agree. Recall the quadratic formula. X equals negative b plus minus the square root of b squared minus 4ac all over 2a. The opposite of negative 5. What am I going to write right there? I heard it. 5. The opposite of negative 5 is a positive 5. What about b squared? Negative 5 times negative 5, that's going to give me a 25 minus 4 times a times c. A is a 2, and C is a negative 1. What about 2 times A? 2 times 2 is going to give me a denominator of 4. I agree. Watch out for those double negatives.
They want me to just patch in the bottom, the square root.
Let me do it like this, and then you patch it in so they can decide how they want to do it. Negative 4 times 2, that's a negative 8, times a negative 1. What's this stuff here going to become?
Negative 4.
Negative 4 times 2 times negative 1. What's that going to give me? A positive 8. So we have a 5 there. We have a 25. Negative times negative gives us a positive 8 all over a denominator of 4. Tony, show
You've already done it.
25 minus 4 times 2 times negative 1. Well, 25 plus 8 is 33, so we agree with Tony's calculator.
Oh, this is not.
Am I going to have an I in my final answer?
No.
No. Can I reduce the square root of 33? Is there a perfect square that divides evenly into 33?
4, 9, 16.
No. The only, let's see, 33. Other than 1 and 33, the only integer factors would be 3 and 11. They're not perfect squares. So can we reduce the square root of 33? No, then you don't have to worry about factoring and canceling. If you don't have a number there in front of that radical, there's no way you can factor and cancel. Here's the final answer. Don't split it up because there's no I. But if you don't have a number there, you can't factor and cancel. Your final answer is that fraction, 5 plus or minus the square root of 33 all over 4. Any questions there? If I'm typing just number over number, you'll see us typing 4/3, and that'll enter the fraction quickly. But if it's any fraction that has anything other than just number over number, I highly recommend that you use the fraction hot button. So there's the bar. Now you know you need a 5 plus or minus the square root of 33 on top. And on the bottom, we have a 4. Any questions there?
Where's the mouse?
Right out there. Number 12.
Okay, let's jump
All
on.
of these are quadratic formula problems. So 10 and 11, I'll leave those for you on your own.
Well,
We're
if we
gonna
have
go-
time,
if
we're
we have
gonna
time, we'll go
back,
back.
but,
Mhm.
but
This is
it's
number
straightforward.
12. Okay, x squared equals 6x minus 13. Once again, it says solve. Oh, and by the way, if you had tried to
Oops, I messed
factor,
up.
what did you do?
I hit 15 something.
Okay, switch to my paper. Suppose I'd said on the last time, 2x squared minus 5x minus 1. Could we factor that thing? Could that have been factored to solve? Did we pick up a square root in our final answer? Yes, that means it is impossible to factor 2x squared minus 5x minus 1. If you could solve it if you could factor it, then great. You could use that, okay? But when you use the quadratic formula and you see that square root, that says it's a good thing we didn't waste our time trying to factor it. That thing is not factorable. I remember there was this algebra book that had a factorability test. The thing under the square root is called the discriminant, b squared minus 4ac. If that's a perfect square, when you're reducing it, if it turns out to be a perfect square, then yes, it could be factored. But if you get something that's not a perfect square, then like 33, then it is not factorable. You could sit here you could sit here for the rest of the year. You're not going to get 2x squared minus 5x minus 1 factored. Looking here at number 12, is this in the desired form? Is this in the form that we want? Descending order on one side and 0 on the other side? No? Okay, where do you think I'm going to get the 0? There's a desire to maybe just pick this up and move it over. But if we pick that x squared up and move it over, that positive 1 that's sitting there in front, what's it going to become over here? A negative. Move the terms around in a way to make sure you have a positive leading coefficient. So I have that x squared. I'm going to leave it there on the left. I'll move that positive 6x. I don't see a sign, so I assume that's positive. I'm going to move that positive 6 over. That's going to become what? So I have x squared minus 6x. What about that negative 13 there? You move it over, that's going to become a. Okay. Now we have it in the desired format. Let's identify A, B, and C. What's A? 1, the coefficient of x squared. What's B? Negative 6. What's C? 13. And don't forget, let's write down that quadratic formula. So we have
You know what? Every one of these that we've done so far, it's worked out that B was negative. Okay?
If B were positive, then what would the negative of that number be? Negative, okay? It's just a coincidence. You're right. We've done 3 of them, and B has always been negative. That is just a coincidence,
Oh, wow.
okay? So what's the opposite of negative 6? If that had been a positive 6, we'd have a negative 6 here. What's B squared?
I think we've done this already. Negative 6 times negative 6.
Positive 36 minus 4 times A times C. Minus 4 times A times C. Okay, so we have 1 and 13 all over 2 times a. 2 times 1 gives me 2. So you know something? Let's use Tony's method for under the radical. For the discriminant, pull up your calculator. I'm getting a 6 minus 52, which is giving me a negative number. 36 minus 4 times 1 times 13. I better look at that. We're getting a negative 16.
That's going to work out really nice.
Is that okay? Just using my calculator. That's a 36 minus 52. That's where we got that negative 16. Any questions on that negative 16? Well, what am I going to have to do with that negative 16? This is the first time this has happened in a while. We have a 6 plus or minus. How is the square root of negative 16 going to reduce? Realize 16 is a perfect square.
But the square root of 16.
Okay. Because it's negative, you know you're going to have an I. The square root of 16 is 4 all over 2.
And this is one of those that
it really doesn't matter. If you factored and canceled, you get the same thing. But if I have a fraction with an I will separate 6 over 2 plus or minus 4i over 2. Look how nicely this reduces. What's that going to reduce to? Here, 6 over 2. 6 divided by 2 is 3, plus or minus, what can I do here?
4 divided by
4
2.
divided by 2 is 2, and don't forget the I. Can I make that a 5i? No, there's no I there, so you can't add it to that. Just 3 plus 2i.
3 plus or minus.
Plus or minus 2i, goodness. 3 plus or minus 2i.
3 plus or minus 2. Hey, I'll use this little I since it's there.
Any questions? I'm going to move, the equation's not in standard form to begin with, I'm going to move the terms around however I have to so that I have a positive A value.
Let me see.
I want a positive A value and I want 0 on the other side. I want a positive A value and I want 0 on the other side.
What about
13. Oh, well. That doesn't look too bad at all. Wow. First, it almost looks factorable, doesn't it?
1 times 2 would give the 2.
But it's not going to subtract to give you a 3. You can't. Yeah.
If this minus had been a plus 2, then it would have factored. But and we would have been doing it because
it's factorable.
Yeah, you're going to show quadratic formula.
Okay.
This one's already in standard form.
Notice it's already in standard form. Square variable, unsquared variable, constant equals 0. And what's my leading coefficient? 1, which is, it's a positive number, a positive 1. So we don't need to move anything. Oh, wow. Maybe this should have been the first one.
Yeah,
what's my A value?
Way over here.
1.
A is 1. What's B? 3. Oh, we finally have a positive B. Okay. C?
-2.
-2. So we write down the quadratic formula.
If you write it down every time you use it, you'll have it memorized before too long. Hold on, Tim. Paul.
Okay, let's fill in the spots. Negative b. I like to write it down like this because then I have something to point at. Negative b. The opposite of b. What's the opposite of positive 3? What am I going to write here? Negative 3. Now, b squared. 3 times 3. What am I going to write here? 9 minus 4 times a times c. And what's here? The a value? 1. The c value? Negative 2. All over the denominator. 2 times 1. What am I going to have down here? 2. I agree.
Now, do you want to race me, Tim?
It's 17. I don't need to race
Negative 4 times 1 times negative 2. Negative 4 times 1 is negative 4 times negative 2 is 8. 9 plus 8 is 17. Oh, that works nice. We have a positive prime number.
Am I going to have it? Okay, wait a minute. Let me write this down. Then I'm going to ask them some questions. I want them to analyze their what their answer is going to look like. Am I going to have an I in my final answer? No. What about, I have a 17 there. Is that a perfect square? Is 17 a perfect square? No. 17 is a prime number. So there's no perfect square factor that we can bring out. Are we going to have to split up? Do we split the things up? You split them up when there's what on top? An I, there's no I. So what am I about to conclude?
Are we finished?
Here's the answer.
Type this in.
The way the numbers are algorithmically generated, I mean, they have it set up so that the numbers aren't awful. Okay, I mean, 17. Couldn't reduce that. Here's our answer. And once again, I've used that fraction hot button to make sure I'm putting everything where I want it. I have a negative 3 plus minus the square root of 17 on top. And on the bottom, I have a 2.
Any problem?
Any questions there?
Anytime you need to step out or something, if you have to leave early, that's fine. That's part of the reason for the videos being posted on YouTube. You know, sometimes it used to be students would say, "Oh, I was absent. I wasn't able to do the homework or something." You don't have. That's not an excuse.
I know.
When someone emails me and says, "Oh, I missed class," what do I say? Watch the video and do the work. And you don't even have to watch this particular, but today's video, the ones that are embedded in the assignment. Oh, this is a good one.
Okay.
I've been wanting one like this.
Okay. I'll make a note next semester. We'll do number 14 early in the assignment, but I won't remember by the time next semester comes around.
Make a note right there on the stuff.
Oh, so make right here, you mean?
Yeah, right there.
2, number 14.
Oh.
No, it's going to be spring 2025.
Oh, wow.
Yeah. Oh, goodness.
Why am I carrying on about this problem? Oh, this is a good one. What's unusual?
Okay, what am I going to do? I've said what I would do in this case, but I don't know if y'all understood it or not. What am I going to do? Okay, I'm going to move. I need a 0 on one side.
It doesn't have to be on the right.
You don't have to have the 0 on the right. You got the 0 on the left. I'm going to pick this negative 5x squared up, move it over, so I have 0 equals. That'll become a positive 5x squared. Then I still have a minus x plus 9.
Any questions on that? You always want, why do we say make sure that the A term is positive? Because in the bottom of a fraction, do you want positive numbers in the bottom of a fraction or negative? That
Don't.
you want a positive number in the bottom of a fraction. You'll never see a negative number in the bottom of a fraction in a final answer. And so if that 2 times A, if you had left A as negative 5, you've got a whole new problem to deal with. You have a negative number in the bottom of a fraction, and your answer should never have a negative denominator. And so,
let's identify A, B, and C. A equals?
They're all ahead of you. 5.
Oh, okay. B equals?
You know a common mistake I've seen students make? They'll say something like B equals negative X. No, no, no. B is, A, B, C must be numbers, not variables.
Okay, be quiet, Tony. What's B?
Negative 1.
Negative 1. And C, I'm sorry, I didn't mean to say that. C is 9.
Now, I bet you that part of this you've already memorized. The first part is what? Negative B. And what's in the bottom? 2A. So, see, you already have that part memorized. Plus, minus, square root. Okay. B squared minus 4AC.
That person couldn't rewrite that formula every time he did an example.
The fact that that was around 30 years ago and you still dwell on it.
I don't dwell on it, I think about it. There's a difference between dwelling and thinking.
Okay. Well, I dwell on the fact the student told me you're just making this stuff work out. It's been 32 years since then.
Okay. Yeah. Negative B, the opposite of negative 1. What am I going to write here?
A 1.
A 1 plus or minus the square root of B squared. What's negative 1 times negative 1? A positive 1 minus 4 times A times C. So we have a 5. And what do we have here? A 9. All over 2 times A. 2 times 5. What have I got down here? A 10.
So that's a positive 10, which is what you want. You'd want. If you had a negative 10 down here, you've got a whole new problem.
So that's what, a 1 minus 180? I'm getting a negative 179. You better check me there.
I've already.
Okay. So we have 1 plus or minus the square root of negative 179 all over 10. Am I going to have an I in my final answer? Do I expect an I? Yes. Okay. Is 179 a perfect square?
Look at your list.
No.
Oh, wait, you want me to punch it in?
Punch it in.
The square root of 179. This calculator doesn't do like the one we looked at on day 1, where it'll reduce it without giving decimals. This one only gives decimals.
Oh, let's see. 179. I don't believe that's reducible. I don't believe there's a perfect square that divides evenly into 179. We can look at the list and start dividing.
Like 81 would be too big.
Mm-hmm.
81 times 2 is, 100 would be too big. 81 doesn't do it.
49, try 49.
Oh, okay, let's see. 49.
Mm-mm.
Does anyone have one of those little nice calculators that does it for you.
I don't need it. 179. The square root of 179 can't be reduced. 1 plus or minus I square root of 179 all over 10. Can I leave it like that if I type that in? Are they going to accept it? No. What am I going to have to do? I have that fraction with that I on top, so I'll do what? Split it up, 1 over 10 plus or minus I square roots of 179 all over 10.
I'm just wondering, like if there hadn't been an I, you would just leave it like this. And it used to be Pearson would let you punch it in like that. But they stopped doing that. I'm not going to try it.
Try
and
it.
give it
I'm
you want
curious.
me to? I'm going to see what happens. If I punch this in, the 1 plus or minus I square root 179
all over 10. I'm just curious.
last semester. Oh,
They
well, I'll be
took-
darned. They took it.
But that's a bad practice, because I assure you, for certain problems like
They
this, with answers like this, they will not take it. Think about I would say dozens, but it's got to be hundreds, thousands of programmers that have worked with Pearson in this program. Okay, if I'm writing the code as it gets bigger and bigger, and then this person goes in and makes changes and stuff. The only way to be guaranteed is if it's an I, to make sure. Now, if it's a homework problem, you type it in as a single fraction and they don't take it, you can type it in correctly. But can you do that on a test? No, the test isn't going to be telling you, oh, that's wrong.
Until the
very end, and then they'll just say, wrong, that's it. So,
Tim, do you want to review multiplying
why
fractions?
don't you review
and
multiplying
cross-canceling?
fractions,
Oh,
okay?
okay.
Tony's going to review. That's one thing he's really good at. Tony knows how to
Tim,
multiply.
shut up. Oh, gosh. In case you're wondering, why am I talking about reviewing fractions? Well, what's hard about this? What looks hard about this problem?
Oh, it's okay. It's already in standard form.
Yeah.
If you're going to use the quadratic formula, we have equals 0 on the
C
one
is
side.
-1.
C is -1. What's A?
Say 1/7.
What?
And B, wouldn't it be easier to not have those fractions there? That's what we're going to do. We're going to rewrite number 15 so we don't have any fractions. But before we do that, let's
Review cross multiplication of fractions.
Okay, let's just, when you're multiplying fractions, if you have something like this, 4 over 5.
Put a little title up there, something like multiplication, recall fraction multiplication.
How to multiply fractions.
Oh, that's good.
So we call how to multiply fractions. Suppose we have 4 over 5 times
7/8.
Oh, I was going to use 15/16, but okay,
that's
7/8. And I'm not sure why I wrote the 7/8 in red. Well, with fraction multiplication, the formal definition is just multiply straight across and then reduce. But there's another way you can multiply fractions with cross multiplying. You can look at the diagonals. Here, 4 and 8. What can I divide both of those by?
Turn around, Tony.
No, it's too much.
Oh, I'm ready.
Oh,
I'm going
okay.
to take the pen. So,
Divide them both by 4.
Divide both of them by 4. Good. Oh,
So 4 divided by 4 is a 1. 8 divided by 4 is a 2. Is there anything we can cross cancel on the other diagonal?
No.
No, so just multiply straight across. 1 times 7 is 7. 5 times 2 is 10. Y'all recall with this when you're multiplying fractions, that's when you can do the cross canceling like that. Suppose we had the fraction 15 over 4 times 10 over 3. Here we can do it. One way you can do it is just multiply straight across. 150 over 12 and then reduce.
The advantage of cross canceling like this is that you don't pick up those big numbers like 150.
Like here, the 15 and 3. I can divide both of those by 3. 3 divided by 3, 1. 15 divided by 3 is 5. What about the 4 and 10? I can divide both of those by 2, so I'd have a 5 there and a 2 there. Now multiplying straight across, 5 times 5 is 25. 2 times 1 is 2.
You can cancel numerator with denominator, or denominator with numerator.
What about this one? 3 over 7 times, oops, let me just keep it the same color, times, suppose this second number isn't a fraction, just times 28.
We'll put a 1 under the...
Okay, y'all hear that? Put it over 1. And now it's the same type of problem. 28, just write it as 28 over 1. Well, there's nothing I can cancel on this denominator, the 3 and 1. But what about the 7 and 28?
7 goes into both of them.
7 goes into both of them, so 7 divided by 7 is 1. 28 divided by 7 is 4. I'm going to wind up with what is my answer? 12. It's 12 over 1. Do I need to write over 1? No. We're going to do something like this multiplying, in order to rewrite number 15 so that we don't have fractions there. So let me go ahead and write down number 15.
Here's number 15. Remember, when solving equations, whatever you do to one side, you got to do to the other side. You can multiply both sides of an equation by any number you want to, as long as it isn't 0, and maintain equality. You can't multiply everything through by 0, because then you turn every equation into 0 equals 0. But you can multiply by anything. I could say I'm going to multiply through by 50 million on both sides, and I'd still have an equivalent equation. But my goal, I want to figure out what should I multiply through by so that I cancel those fractions that appear. What could I multiply? But you know something, you need to look at how Tony wrote the problem. Notice, he's skipping some space, spreading it out. Because we're going to be going through, you can't say, oh, I'm going to multiply this side by, this term here by 50. Because then you got to multiply every term by 50. Whatever you multiply through by, you're not just going to be multiplying the things with the fractions. The way you're going to have to distribute, even the thing that doesn't have a fraction, you're going to have to multiply. The things without fractions. So my question is, what number, what's the smallest number that 7 divides evenly into and 21 divides evenly into?
What number,
7.
like on this one, here, I multiplied by 28 and it completely canceled the 7. So we didn't have a fraction. What number can I multiply through by that'll cancel both of these denominators? Like, not a 7. A 7 would
No, wait. Suppose you put the 7.
Oh, yeah.
We can use our erasable.
If I did, this is, okay, 7. If I went straight through multiplying by 7, with my erasable pens.
You've canceled the first denominator. You've canceled out that first fraction. Have you canceled the second fraction completely out? 7 goes into 21. What have we got down there? A 3. So 7 is not the number we want. We want the number that 7 and 21 would both divide evenly into. 21.
Oh,
Okay.
Tim, this isn't the erasable one you gave me.
Oh.
The erasable is here, and I bet it's not going to erase. Oh, I'll be darned.
Oh my God.
Wow. Are y'all as amazed by this as I am? It wasn't even the erasable pen, but this marker erased.
So the eraser is the secret ingredient.
I
Not
guess
the ink.
so. Okay. So I don't multiply through by 7, multiply through by, let me just do it so you'll see it.
When you're adding fractions, y'all had to find common denominators. If you were going to add the fraction 1/7 or 1/21, your common denominator would be 21. You'd build up to 21. That's what you're going to use. That's called the least common multiple of 7 and 21. If you started listing out the multiples of 7, 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21. Their least common multiple is 21. But notice the way you're having to distribute. Put a parenthesis to get rid of that 15, to distinguish that. That's the problem number, the 15. You're having to distribute 21 over all 3 terms on the left side. And you have to multiply the right side by 21
Why are
also.
we multiplying by 21? Well, let's do that cross canceling. With the 7 and 21, I can divide both of those by 7, and 7 goes into 21 how many times? 3. This 1 over 7x squared is about to become just a 3x squared. This is one of those times when the student could say, you're making this work out. Yeah, that's what I'm doing. I'm getting rid of all of those fractions. I'm making the fractions cancel. Like right here, the 21s, do they cancel? And all we have is what, just 1x?
Yes.
Now,
What have we got here?
-20.
yeah.
Okay, -1 times 21 is a -21. And what about on the right?
0.
0 times anything is 0. Now,
Which one looks easy? Put it on. Which one looks easier to solve? Number 15, for A is 1 over 7, B is 1 over 21, C is -1. Or A is 1, A is 3, B is 1, C is -21. I think this one's going to be the easier one to solve. To use a quadratic formula on. Yes.
So you found the least common multiple of the 2 denominators, which is 21, and then you multiplied that least common multiple by the numerator, and then you simplified it. Is that correct?
Yes, you multiply straight through, and it's the the 7, the denominators will all cross cancel with that least common multiple. Okay?
now realize we're using the smallest number. There are infinitely many numbers you could use. 42.
Any number that would cross cancel with both 7 and 21 would work. You could use 42, like he says.
But then you divide it with 6x squared plus 2x minus 42 equals 0. You have a common multiple there. You're going to have more reduction at the end. To minimize reduction, use the smallest number that divides I mean, that's divisible by every one of the denominators. 7 and 21 are both,
In fact,
no,
for this
21 is
problem,
divisible by
you
7
might make a
and 21.
note. Multiply straight through by the largest denominator. The largest denominator will do it on problem 15. And once we're finished with this, we'll regenerate it once more just so you can see. Multiply through by that smallest denominator, and that'll get rid of the fraction.
No, the largest.
I mean
denominator.
largest. Did I say smallest? I meant largest. Oh my goodness. I'm writing down the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So plus minus square root. Okay, so we're going to get started with negative b. What am I going to write there?
-1.
Negative 1 plus or minus the square root of b squared. We can do that in our head. 1 times 1 is 1. Then minus 4 times a times c. Ooh. A is a 3, and c is a negative 21, all over 2 times a. What am I going to write in the bottom? 6. 2 times 3, 6. Tim, you're going to punch that into your calculator?
1 plus 252 to give me a 253.
Oh, okay. I hadn't seen you'd already done that. So under the square root, negative 4 times 3 is a negative 12, times a negative 21 would be a positive 252. 1 plus 252, 253. So let's see, we have a negative 1 plus or minus, square root of 252.
253.
I mean 253. I know one thing.
Are we going to have an I in our answer?
No, there's no negative under the square root. If it had been a negative 253, then yeah, you'd have an I. 253.
I don't think I don't think we can reduce it. It's not a perfect square. I'm confident of that.
Mm-hmm. It's odd, so it's not going to be divisible
By 2.
by
I
any
do not
multiple
think.
of 2.
I do not think 253 is going to be the
You
square
went
root.
through 253 divided by
253. You go
144,
through 253. Well, it's not going to be an
no. So I'm thinking 253, square root of 253 doesn't simplify. If you want to verify it, punching it into your calculator, 253 divided by 144, 253 divided by 121, 253 divided by 100, and just keep going. You don't even need to test the even numbers because an odd number can't be divisible by an even number. So 8 text 81.
Okay, I'll test it.
Divided by 81. Yeah, it can't be 64. 49. No. So, what am I saying? Am I finished with it?
Do I need to split it up? No. Is there anything to factor and cancel?
No.
No, because there's no number out there. There's the final answer. Here's what I've found from using my lab for years and years and years. If you run into a number, 253, what goes evenly in there? Some big off-the-wall number. Odds favor. They've rigged it so that you don't have to reduce it any further. Maybe there's a negative and you have to bring out an I, but if it's a number that just
Let's
looks
punch
sort of
it
odd,
in.
watch it now say wrong. That there is some obscure perfect square that, let's see, I'm going to punch in my fraction hot button. Then -1 plus minus the square root of 253, and on the bottom I have a 6.
Back in the olden days, and I know this is like when people start talking about, oh, you know, I had to walk to school barefooted in the snow and all of this, but it was a big
Negative
hassle.
1 plus the square root of 253 over 6, comma, negative 1 minus the square root of 253 over 6. Yeah, that was a hassle.
That's why it says use a comma to separate answers. Those instructions were written years and years ago.
Before the plus minus.
Before they had the plus minus button. Now, let's just do one more. Just look at this. Similar question. Tell me what we're going to multiply through by. Click view an example. Or help me solve it, I think will do it.
Yeah.
Okay. If you don't like your answer and you hit click, or you fall, okay. Here, on this one, what am I going to multiply?
We need a number that 2 divides evenly into and 10 divides evenly into. So it can't be smaller than 10. 10 will do it.
Yeah, just multiply straight through by 10.
If you were adding 1/2 plus 1/10, what would you use as your common denominator?
But they're not going to be adding it.
I'm just saying, the number you multiply through is the same number you would have used in the 4th grade when you were adding 1/2 and 1/10 to get a single fraction. It's just that common denominator that you would have used. 10 would work. 10 would cancel them all out. What else would work?
20? Would 20 cancel both of those denominators?
Yes, it would.
30? 100?
Yeah.
But why on earth would you use any number other than 10, the smallest one?
Because then there's less reduction.
Okay? Any questions on that?
I'm going to tell you right now, Wednesday will be one of the roughest assignments of the semester. Normally I don't say that, but I'm saying it right now. I'm just warning you. Now, there's a possibility of some sort of bad weather. Okay, and that Tony and I will be here unless something were to happen and the school were to close. But I believe using our cutting down the trees plus the generator plus the polycarbonate panels,
There won't be that
I don't think we're going to get hit by a bad storm just because the Precella rule. If they spend a whole lot of money preparing for something, then it's never needed. We're saving this city. Okay?
Tim, you're being
I hope.